Hi there, how are you doing today? In this video, we'll talk about different data types that are supported by Oracle database while creating a table. And all these attributes are only supported at the table level, which means that I'm not talking about any data types that are used in procedural language, which is nothing but PL/SQL language available in Oracle database, right? So let's get started. And once we are done with these data types, in the next video, I will be uh, walking through how to create a table, what are different ways to create the table, and different other options, right? All right. So here, if you look at the first column, what I have is like character data type, and it is mentioned 10, which means that it can take up to 10 bytes. So it's one of the data type. And if you look at here, I have mentioned it is a fixed length string. What does it mean? Let's say that if we create a column with data type as char, and then whatever the number you specify, that means its number of bytes. In this case, if you specify 10, that means it takes 10 bytes of space for each and every field. However, we can also specify char, which means that, for example, if I specify something like this means 10 character space is reserved. Ideally, one character is equal to one byte. However, it is not always guaranteed because of different character sets that are available. In general, I mean, like in case if you're showing something in a plain English, assume that it's going to be like one character equal to one byte. So it doesn't make any difference. But if you specify character, that means that it is going to take the space for 10 characters irrespective of the kind of character set that we are going to use to store the data. Now, so here I mentioned char of 10. That means 10 bytes is reserved in this column for each and every field. It is reserved, I mentioned. So what does it mean by reserving, right? So irrespective of whether I insert the value for this particular column, still it's going to hold the memory. It cannot be used by another object. So when do we need to use it? Think of your having a column called active flag to indicate whether it is a yes or no, or you have a gender field which is like male female, something like that, where the values are very less, like very less unique values. In those cases, it's better to use character data type. And what is the disadvantage of using this, right? So as I mentioned earlier, irrespective of whether you insert the value or not, you will not be able to use this memory for some other column, for some other operation. It is always reserved. Then why do we need to use character data type, right? So think of this way, that whenever an SQL is executed in the database, it has to go through something called parsing and then generating a plan, identifying the best way. Part of that, it will also look at the data types and the filters that are applied. So having a character data type will tell the plan that in this string, only these many characters are going to be there always, right? And it is reserved. Whereas the next column, if we look at, which is variable character or varchar, people call it as variable character 2. And here I mentioned 100. Let me just change it to 10. So now we have 10. So what is the difference between char of 10 and varchar 2 of 10? So in this case, again, we are saying that this column can take up to 10 bytes. Up to 10 bytes. We cannot go beyond that. Even if it is char data type, still we can only take up to 10 bytes in this case. In general, character and variable character can take up to 4,000 characters, 32,000 bytes, right? Now, so we have character of 10 and variable character 2 of 10. Then which one do we need to use? So when your values are not going to be constant or less unique values, then probably you want to go with variable character, where the space is not always reserved, it's not fixed. You can insert probably like one character, or you can insert up to 10 characters. It's up to you. So how many characters do you use, so much of memory it takes. Whereas for char data type, if you insert two characters, still it reserves the memory for 10 characters. If you insert 10 characters, it reserves the memory for 10 characters. Either ways, right? So applying the filters on top of variable character 2 may not be always optimal, because it doesn't know how many characters are going to be there in each and every field and how far it has to match. So there is something called as wild character search, which we'll be talking on while selecting the data from a table. But in such kind of situations, probably having a cat data type will be more optimal. But when your values are not going to be less unique, then it's better to use variable character and save the space instead of using the cat data type. Now, the next thing is club. So in this one, so it is ideally C lob, which is called as club, right? LOB stands for large object and C stands for character object. And this can take up to 128 terabytes. In this particular column, we can store the data up to 128 terabytes of data. Uh, One of the scenario I was mentioning when I was segments, if I just take you to the previous window where I was talking about segments and how many segments are going to be there. Ideally, a table can only have one segment. However, when we have a column with club data type, it can have many segments, and each field can also have one segment, right? So that's how it works. So this is character large object, and it can take up to 128 terabytes. So as I mentioned here, this can take up to 4,000 characters, and this can also take up to 4,000 characters or 32,000. And then we have number data type, and here if you see we have three different. First one is number of 10, which means that it can take up to 10 digits irrespective of the precision and scale. However, in the next one I'm specifying that 10 comma 0, which means that it can take 10 digits of precision and it cannot take any scale. Even if you give the scale, it's going to round the number. I'll talk more about it, when we try to insert the data and then when we try to retrieve it, we can get into details and then we can look at it how it behaves. But for now, remember that when I say number of 10 comma 0, that means 10 digits precision and 0 digits scale, right? And the next one we have is float. Ideally, float, there is no such kind of data type called float. Instead, we should use number data type again. But here I'm saying that 10 comma 5, which means that it reserves 5 digits for precision and 5 digits for scale. Are you confused when I say 5 and 5? So let's look at this. If I just change it to 4, 10 comma 4, this means it reserves 6 digits for precision and 4 digits for scale. So what is precision and scale? If I have something like 100.1234, in this case 100 is precision value and 1234 is the scale value, which is after dot, right? So if I say 10 comma 4, that means the value which is before the dot can grow up to 6 digits maximum, and the scale can only take 4 digits. So what does it mean? What if I give 12345? In that case, it will just remove it and it will keep it as 1234. How this rounding works and all, we'll talk about it later on. I'm just letting you know what is the difference between precision and scale in general here, right? So that's about number. So as I mentioned here, there is nothing called integer, binary integer, double integer, float, big integer, nothing as such in Oracle. It is all just number data type, and we can specify how much of precision and scale that can be stored. However, so one thing that I missed to mention over here is like it takes up to 38 digits, which means that number of 38s if you don't specify anything. And within that, the default value will be default of ideally 38 comma 12, which means it takes 26 digits as precision and 12 digits as scale. That's the maximum it can save. And then we have something called date data type, which is widely used. So when you say date data type, and it can also contain the time, not the timestamp. So what is the difference, right? When I say date and time, so right now if you look at the time, it's like 1:30 p.m. Uh, on December 28th, 2024. So it can take the date part, December 28th, 2024, and the time, which is like 1:31 p.m., right? That's the time part it can take, but it will not be able to store the milliseconds, right? At this point of time, what is the millisecond? That it will not be able to store. So why do we really care about the milliseconds? There are systems which needs the milliseconds and microseconds timestamp as well. A column can only hold the date by defining the data type as date. That means it can only have the date and time, but not the milliseconds and microseconds, and not even time zone, in which time zone we are operating. Similarly, the next one we have, which is timestamp. So in this case, we can actually store even the milliseconds as well, along with the date and time. And the next one, as you can see, it can also timestamp if along with the time zone. Something, if you specify timestamp with time zone, that means that in this particular column we are going to store the timestamp, and we can also indicate in which time zone this record was inserted, right? And then we have timestamp with local time zone, and then we have something called, very important, and not many times we really use it, but not many people are aware of this, interval year to month. So let's say that, I will specify that 2024, and then I wanted to say that this is December, just like 2024-12, but I'm not going to specify the date or time or anything as such. I can still store it, and that's a proper data date. A data, a column with a character or variable character, and then I can store it. But later on, we will have to convert the date parameters. Instead, we can use interval year to month data type, and then we can store the year and the month alone. We don't need to store any other, right? And the similar way, we can also have like interval to day to second, and many other ways we can store it, but these are officially supported data types. Then there is something called raw, which is not supported, and it is deprecated. And there are few dictionary tables which are still using raw. However, you won't create it and you won't store any data, right? Then we have something called blob. So similar to blob, so we have blob, which stands for binary large object. Let's say that you wanted to store a movie, you want to save an image in a column, then you can use binary large object. Again, this can grow huge up to terabytes of data, just like blob. Then there is something called XML. So let's say that you have an XML file and you want to save the data as it is, so that the target system which is going to consume can always read the data as it is. And the size of the XML files can grow large, which may not be always under 4000 characters. Then you can actually define the type itself as XML type, and then you can store the XML data as it is and read it as an XML alone. You don't need to read it as a string, right? And then we have something called JSON data types. So let's say that you have a JSON file and you want to store the content as it is, and you also wanted to evaluate whether the format that is being inserted is in JSON format or not. You can still evaluate that. This is the latest feature that has been introduced in Oracle database. As recent technologies are the generation, if you look at, several technologies started adopting as a format to store or exchange the data. So considering that, Oracle also started supporting JSON data type, and in fact you can actually create the indexes as well on top of JSON objects, which we'll be looking at when we deal about JSON data type while creating the table or retrieving the data. And then there are few other data types which are custom data types. Let's have uh, an employee's table, and he has three phone numbers. Ideally, if you want to store three phone numbers, you should be having three columns, or you should be having three rows. So when I say three columns, like phone number one, phone number two, phone number three, something like that, but you don't know how many phone numbers the person is going to have. An organization can have a number of phone numbers as well. And at the same time, if you start putting them into different rows, that means again you're duplicating the data. There is something called as normalization, which I'll be talking later on. But remember that, like, it violates normal forms, right? So it's not an optimal. In such kind of cases, we can actually store it as a nested table, right? It means a table inside a column is called as nested table, which is a user defined data type. And you can insert the data, which means that when you retrieve it, you'll just retrieve it as a single row. But when it is displayed, you can display it as three different rows, and like the same record is going to be expanded and displayed as three different rows. However, if you want to retrieve only one phone number, you can still retrieve that, right? That is basically save the space, and not to duplicate the data. So these are different data types that are supported in Oracle database. Along with that, we also have few things like constraints. We have primary key constraint, unique constraint, and not null constraint. And then we also have something called check constraint, which I'll be talking about later on. And then we have foreign key constraint as well. I'll have a separate video created for this so that we can start looking at the data. We can start creating, we can enforce it, we can I mean enable and disable, we can actually see how the constraint will be enforced, right? And what kind of data will it be supported and everything. So these are different data types that are supported by Oracle database. And in our next video, I'll be talking about how to create the table practically. We'll get our hands dirty. Till then, take care. Bye bye.